tenths. Okay? If we were to reduce this, what would we divide both the top and the bottom by? 12. 24 divided by 12 is 2, and 36 divided by 12 is 3. Just 2 birds. Okay? 2 birds. All right, 45 fiftieths. What did this one simplify to? Yes, Peyton? Someone. What is it? 9 tenths. There you go. And 88 and 1/21. Yes, Julia. 8 elevenths. Okay. I just noticed on number 2 you divide by 5 on both. And 3 you divide by 11. Alright, we've already defined what a rational number is. Okay. It's any number that can be written as a fraction without decimals, or it can be any repeating or terminating decimal. That's all this stuff is saying here, okay? This stuff. Down here at the bottom, all we're going to do is take these numbers right up in here and put them where they belong in here. All right? So let's start with 0.8. Is it a whole number? Is it an integer? Is it a rational number? Is it rational? Yes, it be. So we'll just put it in there. Good. So we've done this one. All right, 2.2 repeating. Whole numbers. Integers. Rational. Very good. There you go. -1. Is it a whole number? Is it an integer? Yes, it be. Is 1 a whole number? Yep. And we're just left with this final one, 1 and 2 thirds. Okay? There's your answers. All right, the common denominator is when the denominators of 2 or more fractions are the same, like Ashley said. Okay? So if we were to look at this, let's look at an example very quick. Uh-oh. That's very big. All right. If we have this example, give me a number. 4. Uh-oh. 4. We'll make the 8 over. Oh, sure. 29ths. Okay? And let's make this 61s. All right, if we were to compare these two numbers, what we would do to find common denominators. This is very important, you guys, to remember, because it's one of the easiest ways I know to find a common denominator. Now, some of you are thinking already that you want the least common denominator. That's going to be very difficult with these two large numbers, 29 and 61. So, the easier way to do it, oh, what the heck. Anyways, what we need to do is we're just going to take these two. We'll take 29, for example, and see 29. What I'm going to do is multiply it by onto the other fraction in both the numerator and denominator. So times by 29 times by 29. Okay? What this does is it gives me an automatic denominator of, it's going to be a large number. Someone figure this out on a calculator. All right, so we have 1,769, and then 8 times 29, 232. Very good. Okay. Now, when we do this other side, what we're going to do is we're going to take the 61 now and multiply it over here. Well, we already did 61 times 29. It's going to be the same denominator. Okay, and that's what we're looking for. That's the main idea with this, is that you be able to find a common denominator. Okay? But we also have to do it with the 4 times 61. So 244. Is that correct? All right, notice the value of these two is very, very close. We can ignore the denominators because they are now the same. And we just need to compare these two. So which one's bigger? 244. So now we could say absolutely, positively that this fraction are the biggest. It's the biggest one. Let's show you guys something else here, okay? Another way to find common denominators. So if, for example, let's take, well, just give me some fractions here.
2 and 3/4.
Oh, let's do 2/3. That's a common one. Let's also do something like, well, let's do 15. Yeah. Oh, well, 18ths, okay? Whatever. All right. Now, in order to find a common denominator here, and some of you are thinking in the opposite direction, you're going to reduce. That's fine, except for it won't be common denominators, all right? So what we're going to do, now some of you have noticed this, that there's an easy way to find a common denominator with this. So you may know that 18 is a multiple of 3. So what you're going to do is take the 3 and multiply it by 6, and the 2 as well, and multiply it by 6. Then we can compare. 6 times 2, 12. Over 6 times 3, 18. Now our other fraction was 15 over 18, okay? Now in some cases on the homework tonight, what you're going to have to do is represent this, that it is greater than, all right? So you'd say it's greater than. Some of you remember doing this from back in elementary. And what did they tell you that was?
An alligator mouth.
Yeah, right. So you put some teeth on, and you draw your little alligator. Listen, I'm a math guy, not art guy, okay? Oh, well, thank you. That's very nice of you guys. But in addition to this, because we're no longer in elementary, guys, so what you need to remember is that things are a little bit different. Now it's both a shark and an alligator. It's a shalligator. However, we can't stop there, right? So what we must do is give this thing some wings. All right? Now, when this happens, those are bat wings, guys. So it's a mixture between a shark, alligator, and a bat. It's a shalligat. All right? So get rid of all those memories of alligators eating numbers. It is now a shalligat. Okay? Oh, thank you. All right, now listen, let's look at one more example. Because there is a different way that we can do this, and it's, as it turns out, much easier than either of those two ways, because it takes less thinking. And this is a math class where thinking is highly discouraged, okay? So, when we do our thinking, let's look at another fraction, okay? Someone, give me a fraction. We'll get there. Well, hold on though. Let's make it 16 nines. Because that's improper, and we haven't done one of those yet, okay?
1 and 5 6.
Let's also make it, well, let's make it improper, okay? 1 and 5 sixths would be 11 sixths. All right. Now, I'm only going to share this with you guys once, unless you ask again. Okay, so pay attention. No, you do not. That's a lie. All right, what I would do is I would take this fraction. Oh, you can't see that very well. I would take this fraction, and I would put it into the calculator. 16 divided by 9. What does that give you on the calculator?
Oh, I can find out.
1.77. No, it's definitely not 1.78. It's 1.7 repeating.
calculator.
All right, now what we also need to do is this other one right over here, okay? So someone in their calculator put 11.6.
1.83 repeated.
What?
1.83 repeated.
1.8. Is it just the 3 that repeats?
Yeah. Yes.
Okay, good. 3 repeatons, okay? Whatever. So what we end up with here is we have to compare first the number in the ones position because we have numbers in the ones. Are those numbers the same? Yes, they are, okay? So the 1 is not going to help us. What we need to do now is look now in the tenths position. Notice we have an 8 and we have a 7. Which is bigger? 8. So these other numbers don't matter to us either. This one's bigger. No. All right. For example, let's look at some more of these. Let's take 3/4 and also 7. Well, would that be 3 and 11ths? 7/11ths. Now here's the thing: is many of you know that 3/4 is 0.75, right? 7/11ths. I don't know what that is. 0.21. Repeating.
Oh, I can find out.
Point.
It's point
It's 6.36.
Like this. Okay. Now, here's what we have to do, is we have to look at these. And this is going to change, what I'm about to do is about to change your life forever. Whether it is for good or for bad, it is up to you. There you go. Now that these are negative, it changes everything. Okay? Because now if I look down here, I have a negative 0.75 and a negative 0.63. Look at this. Would you guys rather owe me 75 cents or 63 cents? Yeah, you would rather owe me the 63. So this is the answer. Okay, this negative right here, it changes everything. Like meal. All right. This example is in your book. Notice it says we got to fill this. We got to fill this in, right? Which it was not filled in before. But if you get two numbers that are exactly the same, like these two are, you just put an equal sign in there, okay?
Oh, so just like normal?
No signs. All right. On these three numbers, we need to set in order from least to greatest, okay? So if we look at this, 7.49 is already decimal. I have 7 units in this one, point. If I do 49 divided by 50, I will have 0.98. All right? Here's the thing with decimals. 7.5%. Notice how we've got this circle here in this one? That tells us how many times we must move the decimal. And in this case, there's 2. So I move it 2 to the left. If there's an empty space, I make it a 0. So this number here now becomes 0.75. Yes, thank you. I meant, yes, that. What? There we go. 0.075. Thank you. All right. All right. So which of these has the smallest value? Yeah, 0.075. So we've used this one. The next one. What is the next biggest? We've only got these two numbers. Which of these two are bigger?
The middle one.
Yeah, very good. Oh, yeah, 7.98 is bigger, so it would be our final number. Which means our middle number is 7.49. I kind of skipped around there, but you can do it in order, okay? All right, there's your answers, and it's the same. Notice all that's different is that the book put these back into their original form. All right? Okay. Yeah, here's another example in the book. So on this one, this has negatives as well. And so we want the smaller absolute value, which would be -1 and 1/6, okay? There we go. All right, here's A. Do A. You do not have to use the number line if you do not want to. All right, on this problem, would someone like to solve this one for us? Just circle the one that's bigger. Okay, Sam.
that right.
Go.
I think I can do this.
That's snazzy. Just circle it.
Don't mess up.
Okay.
That's so snazzy.
That's so classic.
All right, well, thank you very much. Also, it's incorrect. It is. Okay. Sorry. Okay. I think Sam just kind of glanced at that without truly answering, okay? Why is that incorrect? I need someone just to explain why it is. Sierra?
Well, because it's a negative, it's the smaller number.
Yeah, very good. Sam, does that make sense?
That makes a lot of sense.
Very good. Since it is negative, we want this one. All right.
Hey, it's red.
Red is right.
Red is right.
All right. Very good. So it was this one. All right, here's another example where you got to fill in this. Notice in this example from the book, they're using the least common denominator. All right. You can see that 36 is the least common one between these two. However, you could have used the same technique that we did earlier where you multiplied 12 here and multiplied 18 here as well. All right, here are 3 more examples. Please do them. B, please. Thank you.
Okay.
Come on, Carly. The video is waiting.
Go to the middle. So 54. 4. What time for my work?
Very good. Excellent work, Carly. Would someone like to explain how she got this? Who will explain for us how she obtained this? Yes. What's your name again?
Brigham.
Oh, Brigham.
I explain it on the iPad.
Yeah, explain it on the iPad. You don't need this.
Oh, so no. She multiplied.
Hey, you gotta talk loud, dude.
She multiplied 9 and 6 together and got 54. And then on 5/6, she times it by 9. So she got 45 as her numerator. And she did the same thing on the other side, but with 6. So she got 42 as her numerator. Bam.
Bam. That's good. Thank you, Brigham.
I feel him.
All right, would someone like to do C for us on the iPad?
Mr. Sal, can I go get a drink? So I can
All right.
stop?
Caleb?
Yeah.
Caleb's going to do it.
Wait, I can't. Mr. Sal. Yes.
Teach.
Don't get a whiteboard mark. Wait, what?
Why are we laughing?
I did not say that.
I can bullied and you are not
Oh, hey, Caleb's trying to explain this on the iPad.
It says, be the one.
My face. What the heck? That's crazy.
Okay. Thank you very much. Notice, Caleb, right? Yeah, Caleb. Caleb found the least common denominators between these two, which, as it turns out, is 50. And it is true, 10 over 50 is bigger than 7 over 50. Excellent work. All right, who would like to solve D for us, please? All right. In the back, Heidi, right?
Okay, good. Because you're about to pick
Yes,
me
all
up.
right. Heidi's going to explain this one for us on the iPad. They should be talking. Heidi.
What?
Heidi should be talking.
We're writing.
All right, very good. Excellent. Thank you. All right. Now notice Heidi. What she's done is she's indicated that this one is bigger. Huh? What do you mean no?
Yes. Yes.
Okay, this one is the bigger one because it are negative.
That's what I got.
Okay. Excellent work. All right, I'm gonna. All right, here, let's look at this example. Oh, you can't see that very well. All right, example, let's take 3/5. Let's make it 300/5, okay? And it's negative. Is this bigger than 4/5?
No, it's smaller. Yeah, it's smaller because it's negative.
Yeah, it's smaller because, yeah, notice it's 300, which is bigger than 4, but it's the negative, okay? So the 4/5 is bigger, okay? If ever you're comparing two numbers and one of them's negative, it's automatically smaller. All right, here's another example. This is a word problem, which you guys love and enjoy. Notice, this one we want to know which class has a greater fraction of students that own roller shoes. Well, in Mr. Huang's class, it's 20%. What is 20% as a decimal?
0.20.
0.2 or 0.20, 0.20. Okay? Now look at Miss Trevino's class. It's 5 out of 29. 5 out of 29, as you can see here, would give you 0.1724 garbage. All right? So, since this one is smaller than this one, 0.2 is bigger. So, it looks like Mr. Huang's class has more students that own roller shoes. Yes. All right, Dewey. All right. Here we've got 37.5 percentages. What is 37.5% as a decimal? Bridger.
0.375.
Excellent. And then we've got 12 out of 29. What's 12 over 29 as a decimal?
I don't
Lonnie.
know.
0.4? Seems like there should be more.
Let me do it. Let me do it. 12.
0.14, 0.4.
377.
Sure, 7's good. Thank you. All right. Notice in this one we do need to compare the tens position, okay? And since this one is smaller than this, bam. Okay? So it looks like, now listen, that's not the final answer to this. The question was, in which class does a greater fraction of students like to bowl? It's fifth period, okay? So it's a fifth period.
What the heck?
Wait, how is it 5:30? Oh, wait. Oh, I get it.
Look, F is just another ordering problem like we did before, with less clutter. Thank you. Okay? Notice on number 4, an example 4 though, it does have pi.
Pie chart.
If you don't know what the value of pi is,
It's 6.
the calculator does, and it has a pi button.
Oh, pie poo?
Alright, just real quick, for those of you who don't remember how to turn a percent to a decimal,
0.23 over 100. Which is the same as 0.2.
I aired the calculator.
There we go. Alright, what you're going to do is you're going to take 23%, and you're going to move the decimal twice. It comes out to 0.23. Alright, our next value is 0.21. 1/4 is 0.25. And 1/5 is 0.2 or 0.20. Okay? Now, here's the thing is, guys, is this wants us from least to greatest. So we start with the least. Okay, they all have the same tenths value, place value. We are. And so we have to go to the hundredths. 0 is the smallest of them, so 0.20 is the least. Bam. Cross her out. Next one is 0.21. Bam. Cross her out. 0.23. Shazam. Finally, 0.25. Slam-a-lam-a ding-dong. Okay? That's a doo-wop. Alright, it's a good question. Sierra says, well, wouldn't we have to make these all back to what they originally were up in here? Yeah, that's fine. Okay, so what you do is you put 1/5, 0.21, 23 percentages, and 1/4.
I did that myself.
Everyone did it but Sam. This example's in the book, and it is for your reading enjoyment. You start on the homework.